Good morning. In the last lesson, we talked about how to identify GCFs and factors of terms. So you did this, or you should be doing this as a warm-up with your class, and then we will move along and simplify or factor polynomials using the greatest common factor, which you learned how to use in the lesson yesterday. So, factoring the greatest common factor, what you need to do is find the largest number and or variable all terms of an expression can be divided by. What number do all the coefficients and constants divide by, and what's the lowest power of all of the same variable? Okay, and what we're going to do is we're going to kind of pull those out front, and I want you to think of this as undistributing. Okay, so when I look at 30, 42, and 36, I know that I can divide all of those by 6. I'm going to use a -6 because they're all also negative. So I can divide every term by -6. So that's that number part, okay? The second part is looking at the variables. What variables do all of the terms have in common? Well, notice these first two have n's, but that third one doesn't. So we can't actually factor out an n since there's not an n in every term. So what we're going to do is just divide everything by -6. So -30 divided by -6 gives me a positive 5n squared. Okay, so -30 divided by -6 equals 5. Okay, we're going to do -42 divided by -6, which gives us a positive 7. And then we're going to do -36 divided by -6, which gives you a positive 6. Okay, this is our factored form. We have to make sure we can't divide anything else out, but we are in pretty good shape there. Okay, the second one here is a little different. This time I need to compare my coefficients, and I know that I can divide each of those terms by 7. Then I need to look at the variables, and you'll notice this time all three terms have an n in them. Okay, so I know they have an n in common. I need to look for the smallest exponent because that's the fewest number that a term has, and that's all I can take out. I can't take out the most. So the smallest exponent here is 2. So what we're going to do is we're going to divide every single term by 7n squared. So we're going to do 63n squared divided by 7n squared. Well, n squared divided by n squared is 1, and 63 divided by 7 is 9. We're going to do the same thing with 42n to the 4th and divide by 7n squared. And this one's a little different, and if you think back, there was an activity we were supposed to go through before last unit where we look at our exponents. If I have 4 n's here and 2 n's here and I simplify it, I really have just 2 n's left on top. And then 42 divided by 7 is 6, so I have 6n squared. And then the last one, 35n to the 3rd divided by 7n squared. Again, I have 3 on top and 2 on bottom, so if I start simplifying, the 2 cancel with 2 of these, so I really just have an n left there. And 35 divided by 7 is 5 with my n. Okay, now the easiest way to check your work on both of these is to distribute that back through. Okay, let's do a few more. Next one. I can divide 6, 2, and 2 all by 2. And notice we have b's in every term, and this is really a 1 here. So the smallest exponent in those is 1. So I have 2b to the first on the outside. So 6 divided by 2 is 3. If I have 4 b's here and I took one of them away, or took one of them out, I have 3 left. 2 divided by 2 is 1. I'm going to write it there for you. You don't have to. But if I had 2 b's and I took one of those b's out, I have 1 b left. And then for the last one, 2 divided by 2 is also 1. But if I had just 1 b and I took that b out, there aren't any b's left. Let's go ahead and erase those 1s because we don't really need this one here or this one here. Let me fix that b. And then this is typically what you'll see in a book or in examples. moving on to the next one. I can divide 24, 8, and 20 all by 4. And then if I look at my variables, I have n's in each term, but the smallest exponent is a 5. So I'm going to use the n to the 5th power. Okay, so 24 divided by 4 is 6. If I have 8 n's and I take 5 away, I have 3 left. Negative 8 divided by 4 is negative 2. If I have 7 n's and I take 5 away, or take 5 out, I have 2 left. And then negative 20 divided by 4 is negative 5. If I have 5 n's and I took 5 out, I don't have any n's left. The next group has more than one variable in it, which is okay. Still follow the same process. So 21, 27, and 12, I can divide all of those by 3. And then you'll notice that all 3 of those terms have variables, but they don't all have y's. So I can't use a y in my GCF that I'm pulling out. I can only use an x, and I'm going to use that smallest exponent that I just wrote there, which is x to the first. So 21 divided by 3 is 7. If I have 3 x's and I take 1 away, or take 1 out, I have 2 x's left, and I didn't do anything with my y's, so that's going to stay the same. 27 divided by 3 is 9. If I had 3 x's and I took 1 out, I have 2 left, and then we didn't change the y at all. And then negative 12 divided by 3 is negative 4. I had 1 x, took that x out, so there aren't any variables left. Next one, 60, 20, 90. I can divide them all by 10. Notice they all have a's. The smallest exponent for our a is 1. And they all also have b's. Smallest exponent for our b is 2. So negative 60 divided by 10 is negative 6. I had 2 a's and took 1 out, so I have 1 left. And I had 3 b's and took 2 out, so I have 1 left. 20 divided by 10 is 2. I had 2 a's and I took 1 out, so I have 1 a left. I had 2 b's and I took 2 out, so I don't have any left. Okay, last one, 90 divided by 10 is 9. I had 1 a and took it out, so there aren't any a's left. And I had 3 b's and took 2 out, so there's 1 b left. I'm going to go ahead and stop here. I'm going to have you pause and try those last 2 problems. And then when you are ready, go ahead and hit play again to check your answers. Okay, here you'll see that I had a 5 that goes into all of those terms, and then I have u to the first, v to the second, and I divided all those out to get v, 4uv squared plus 3u squared plus 8. And then for the next one, if you took out a positive 4, that's okay. These will just be negative on the inside. And then they had a y squared in common, and that's it, because the second term doesn't have an x. So you are left with technically a 1, x to the third, y to the fourth, plus 6. If you did not take out the negative and you wrote it this way, you're going to end up with a negative x to the third, y to the fourth, minus 6. Okay, so I would actually take either one of those. One thing I want you to notice is I did switch the order because typically we write our x first and not our y. If you have any questions, please speak up and ask now. If not, go ahead and try the practice in your packet and check your answers. And again, let us know if you need any help. Have a great day.